Hello and welcome to GatorBreaker, the game of Breakout just for Gators. When you start the game, you'll be met with a title screen and a Gator split in half, and then 3 options. So it's a game of Breakout, and the slow option, it has the slowest possible maximum speed for the balls, and the impossible option has the fastest maximum speed for the balls. The impossible option has more lives, and the slowest option has the least amount of lives. So trade-offs. When you start the game, you'll be met with the Gator running across the screen and a lives counter in the top right and points counter in the top left. Every time you get a block broken, the points counter goes up, and every time you lose a ball when it crosses the bottom of the screen, you lose a life. And each block has a 10% chance of creating a new ball, as you can see there. And when it does, the lives go up, and the lives go down when it gets off the screen again. And so if you play the game and you lose all your lives, you'll be met with a losing screen. And so everything turns red, it tells you that you've lost, and it tells you how many points you've accumulated throughout the game. So we're about to see that right now. And it says, that's disappointing, you did it, you lost. And it tells you how many points you were able to accumulate throughout the game. And so right here we can see 34 points, and if you want to play again, you just wiggle the joystick. And so if we play the impossible mode this time, the balls will be much faster. And you can see that the game is controlled by the accelerometer on the board. So if we spawn another ball, it'll move slowly in the beginning so you could start, and then it'll move very quickly in impossible mode. And if you find that impossible mode is just too hard, or any of the modes are too hard, you can click again while there is a ball on the screen, and it'll start bouncing off the bottom of the screen. And so if we let this run for a while, it'll start to add more balls because of the 10% chance that each block has of adding another ball. And soon a maximum of 7 balls will be created, and it's very exponential. And it'll remove all the blocks from the screen once they're made in contact with each ball. And as the balls get deleted, it's getting closer to the winning condition of all the balls being destroyed. And when we get to that, you'll see a green screen. It'll tell you all the points that you got from deleting all the balls. And you'll have another option to play the game again. So congratulations, player, you did it, you won. And it tells you how many points, and you can wiggle the joystick to play again. And that's the game. So this game is controlled by 13 threads, 3 of which are periodic. And so we have the paddle thread. This controls the movement of the paddle. The draw obstacles thread, which draws the obstacles at the beginning of a game. The create ball thread, which creates a ball and all the parameters it needs whenever you click the button or whenever a block breaking creates a ball. The update P&L thread updates the points and lives at the top of the scoreboard. Idle thread exists for when there are no other threads running. Then joystick write and joystick read threads. These are the threads that read from the joystick and store the data in a FIFO. Then the main menu, game start, and game end threads draw all the graphics for when the game starts and ends and determine when the game starts and ends. And the main menu thread controls the options on the main menu. So the periodic threads, we have a thread that reads the accelerometer, and then a thread that reads from the FIFO for each direction in the accelerometer. And then we have a thread that fixes the screen. So every about 5 seconds, it refreshes the screen because this LCD screen has a known error that has a random chance of flipping the X and Y directions of the screen and inverting some of the colors. When the game begins, the main menu thread is added, and when the game begins, it also starts off in the 0 state. And so when it enters this thread, the joystick threads are added, and the game start thread is added. So if the joystick is pointed in one direction, then the option number increases, and if it goes over, then it circles back to the first option, and the other direction is the opposite of that. And then once the button is pressed, then the setting is chosen based on the option for the number of lives and the maximum speed, and then the state is set to 1 for the game to start. And so the joystick is no longer needed, so those threads are removed from the list of active threads, and then the main menu thread is added again. So if we look at the main menu thread, the state has changed to 1, and then we add the thread that updates the points and lives at the top of the screen. We add the threads that allows balls to be created. We add the thread that draws the obstacles, and we add the thread that controls the paddle. One thread I haven't mentioned yet is the ball thread, and this ball thread is created by the create ball thread whenever a button is pressed or a ball is created by a block being deleted. And so what this thread does is it determines the new position of each ball based on the speed. However, there are a couple conditions where the new position isn't just based on the speed, and that is when it is about to collide with something. So if the ball is set to collide with a side of the game, or with a block, or with a paddle, it's supposed to bounce off those surfaces. And for the paddle, there's a special condition where depending on where on the paddle it hits, it has a different speed in the X direction. So if you notice, this ball bouncing back and forth has been in the middle of the paddle, so it's just going up and down. But if I move it a little bit more, if I move the paddle a little bit, you can see that it hits a different part of the paddle and has a different angle now. And for the blocks, it's kind of difficult to determine which block is really being hit for each ball. And so there is a process to how object detection works for the obstacles. The way that object detection works for the obstacles is that each ball loops through the obstacles in the game and checks whether it's been broken yet, and then checks whether the ball is within the range of the obstacle. And if so, the game calculates the distance from the ball to the current block being examined. And if that distance is the minimum from all the other blocks that have been detected as having some kind of collision, then it chooses that block as the block that's being collided with. Once we know which block is colliding with the ball, we can remove that block, we can increment the point counter, and if that block is able to create a ball, we create that ball. And then we have to figure out how to reflect the ball from that block. Because of the limitations of the speed of the LCD screen, the ball can move in either X or Y direction for a maximum of 6 pixels. And when that's the case, it can be difficult to figure out which obstacle the ball is colliding with. So the way that it works in this program is that we take the old position of the ball, which is the faded pink block, and we take the new position of the ball, which is the brighter pink block, and then we take the position of each blue block, which are the obstacles. And so we look at the new position of the ball, and if that position is within the same coordinates as any of the obstacles, we then loop through each obstacle that the ball seemingly collided with, and we calculate the distance from this obstacle, or from each obstacle, to the old position of the ball. And based on that, we can determine which block is being collided with. So in this scenario, it seems that this block is the closest to the previous position of the ball, and so we would say that this block is the one that we are colliding with. So now that we know that the ball is colliding with this block, we need to figure out what direction it's going in, and there are 8 different options for that. It could be going down and right, just down, down and left, just left, up and left, just up and right, just right, and for this demonstration, it's clear that the ball is going down and right. Since we know now which block we are colliding with and the direction we're going in, we need to figure out whether we're hitting the top edge of the block or the left edge. And so since in this scenario, the rightmost pixel of the ball is in line with or greater than the leftmost pixel of the obstacle, we know that we are definitely going to hit the top edge of the block. If we were in the scenario where the bottommost pixel of the ball were in line with or greater than the topmost pixel of the obstacle, we know that we're definitely going to hit the left side. However, in the scenario where that's not the case, it's not as easy to determine. In this scenario where it's not clear which edge the ball is going to collide with, we can take the difference between the slope of the corner of the old position of the ball and the corner of the obstacle, and the slope from the corner of the old position of the ball to the new position of the ball. And so you can see if the slope between the old position of the ball and the corner is less than the slope from the old position to the ball to the new position of the ball, we can confidently assume that we are hitting the right edge of the obstacle, and this would be the new ball position. And if we were going to hit the top edge of the ball, the same principle applies, except the slope from the corner of the old position to the obstacle is greater than the slope from the old position to the new position of the ball. And in this scenario, we can see that clearly we are colliding with the top edge. Now, if we want ball collision to look clean, that means that we never want the new position of the ball to be inside an obstacle. We want the position of the ball to be on the edge of the obstacle, and that would just be the average between the positions of the old position and the new position. So that'd be right around here. However, in the scenario where the average would be inside of another obstacle, that creates problems because we never want the new position of the ball to be inside an obstacle. So we snap that back to the closest position where it's not in an obstacle, and we carry on with the rest of the collisions that we experience in the game. So when we put that into practice, we can see that the collisions in the game are very clean and bounce off the edges of the blocks exactly how they're intended to. And in this scenario where it's almost a corner, you can see that it'll go up to the top block and then it'll bounce off.